Imagine that 85% of everything that exists in the universe is completely invisible to us. It's not that it's hidden or too far away. We simply can't see it, touch it, or detect it with any instrument we've ever invented. This mysterious thing is everywhere around us, passing through you at this exact moment as if you didn't even exist. Scientists call it dark matter, and it holds galaxies together like invisible glue. Without it, stars would fly away, and nothing we know would exist. But here's the scariest part. After decades of searching, we still have no idea what this thing really is. How can something that controls the fate of the entire universe be so impossible to find? Subscribe to the channel, leave your like and comment from what part of the world you're watching, because now I'm going to tell you everything. Have you ever wondered if there is something all around us that we cannot see or touch? In the universe, there is a very special kind of matter called dark matter. Most people never notice it because it is completely invisible. It does not make any light. It does not shine, glow, or reflect anything. If you look up at the night sky or through the world's most powerful telescope, you will not see dark matter by looking directly at it. No machine or camera has ever taken a picture of it. Yet all the signs point to it being there, everywhere around us, all the time. What is dark matter? Dark matter is matter that is different from anything you can see, feel, or touch every day. When you look around, you see many things made of regular matter. The chair you sit on, the ground you walk on, the air you breathe, the sun and stars you see at night. These are all made from regular matter. You know regular matter because you can see it and sometimes even touch or hold it. But dark matter is not like this. It cannot be seen. It cannot be touched, tasted, or smelled. It does not interact with light or waves from the sun or from any lamp. This is why dark matter is called dark. Even though dark matter is hidden in this way, scientists are sure that it exists. This is because when they study space, they notice effects that cannot be explained with regular matter alone. If you could somehow count all the matter in the universe, dark matter would be most of it. Scientists think that almost 85% of all matter, meaning almost all of it, is dark matter. Only about 15% is regular matter, everything you see and everything you have ever touched. So most of the universe, almost all of it, is made up of something that is invisible and unknown. How did scientists find out about something they cannot see or touch? It is because dark matter changes the way things move in space. When scientists look at galaxies, which are huge groups of stars far away in space, they see something strange. The stars in these galaxies spin or move around their centers much faster than they should be able to. If only the regular matter we can see was there, these galaxies would not stay together. The stars would move away from each other, or they would drift apart. But this does not happen. The galaxies stay together and the stars keep spinning around fast. The only way scientists can explain this is if something else, something invisible, is also there. This invisible thing has mass and it pulls with gravity. They call it dark matter. Gravity is the force that every bit of matter makes. Gravity pulls things together. You can feel gravity when you drop something and it falls down. The earth has gravity and it keeps you and everything else on the ground. Regular matter creates gravity, and so does dark matter. When scientists study the way galaxies move, they see that some kind of extra gravity keeps everything together, and this extra gravity comes from dark matter. Scientists use telescopes to look at the sky and see how things move. When they look at different galaxies again and again, they see the same thing. Stars are spinning too fast to stay together if only regular matter was there. Many tests and calculations show the same answer. There has to be more mass than we can see. The galaxies are behaving as if something else is holding them together. Scientists worked for many years to find another answer, but there was no other way to explain it. This is why scientists are sure that dark matter is real, even if they cannot see or touch it directly. The difference between regular matter and dark matter is very important. Regular matter is everything familiar. You can see it, feel it, and it can make, reflect, or block light. That is why you are able to see a tree, a car, or a star. Dark matter does not make any light or heat and does not show itself in pictures, scans, or any tool that looks for light. It is completely invisible to all of these. Scientists only find clues that it is there because of how much gravity it has. Even though we cannot see dark matter, we can see the effect it has on space. People sometimes wonder, if dark matter is all around, why do we not notice it in our own lives? The answer is because dark matter does not do anything to us in a way we can feel, see, or measure with simple tools. It does not make noise. It does not block the sun or cover the stars. Dark matter can go right through ordinary matter. It does not get stopped by walls, by the atmosphere, or by your body. It keeps moving, and for us, it passes by without a sign. On Earth or in your house, the strength of dark matter is so weak that you do not notice it at all. Still, dark matter is very important for the universe. Without it, things would not look the same. If galaxies did not have enough gravity, they would not hold together. Stars would not stay in their places. The galaxies might fly apart, and maybe even life on planets would not be possible. Many scientists believe that dark matter is needed for galaxies to form and grow. They think that, in the early universe, when everything was new, dark matter helped pull things together so galaxies could form. Now, dark matter still holds galaxies together, making the universe what it is today. There are other clues that dark matter is real and everywhere around us. One of these clues comes from something called gravitational lensing. Light, which travels in straight lines, can bend if it passes near a lot of mass, such as a very big star or a group of galaxies. This bending of light is called gravitational lensing. Sometimes scientists see that light from far away bends much more than it should. There is not enough visible matter to cause that much bending. The only way to explain it is if there is extra mass, something we cannot see. This extra mass is thought to be dark matter. It means that dark matter can pull on light with gravity, even if it cannot give off or block light itself. This is one more reason that scientists are sure dark matter is there, even if it is invisible. When scientists talk about the universe, they like to divide matter into two types: regular matter and dark matter. Imagine you had all the stars, planets, air, water, people, and everything else that you can see. This is regular matter. Now, in space, there is about 5 or 6 times more dark matter than regular matter. So, for every star or planet you see, there is much more that is hidden. In fact, the universe is mostly made of dark matter. That means when you look at the universe, you are only seeing a small piece. The biggest part is invisible, but its effects are big and important. Even though dark matter is everywhere in the universe, we do not know what it is made of. It is not made of the same things as regular matter. For example, regular matter is made from tiny things called atoms. Atoms have a center called a nucleus and smaller parts that move around it. Dark matter cannot be any of these because it does not act the same way. It does not interact with atoms in the ways we expect. Scientists have many ideas, but they do not know for sure what dark matter is. There are many questions left to answer. What makes dark matter different from regular matter? Why does it not show itself? If it is everywhere, why does it not interact with us? Scientists do experiments to try to find out. They look for dark matter deep underground, in special places where nothing else can get in the way. They watch the sky and look for special signs in very old light from when the universe began. They use powerful computers to make models, to see how the universe would look with and without dark matter. If the models without dark matter do not match what we see, then dark matter is needed. For now, what we know is that dark matter is real, even if it is still a mystery. It is present in the universe. It holds galaxies together. It helps create the shapes we see in the night sky. It makes up most of what exists, but it hides from our eyes and our tools. It does not act or react with light like normal matter. All of our most clever machines can only see what regular matter does. With dark matter, we see its effect, its pull, and the way it changes things around it. If you look at pictures of galaxies and the universe, remember that much of what is really there cannot be seen at all. The shapes and movements you notice in these pictures only happen because of all the dark matter in space. Without it, the universe would look, spin, and move in a very different way. Even though no one has seen or touched dark matter, its story is written in the way stars move, in the shapes of galaxies, and in the bending of light from far away. Every scientist who tries to understand the universe must also think about dark matter, because it is the main thing holding the universe together. The mystery of dark matter invites us to keep looking and learning. It reminds us that there is much more out in space than we can see, more than we can even imagine. Everything we do discover brings us closer to understanding what makes up our universe and how all things stay together, even when most of them are hidden. For now, we know that regular matter is just a small part and that dark matter is huge. This is a big step for science, but there are still many questions left to answer. In our universe, there are two main kinds of matter. One kind is regular matter, which is all around you. The other kind is dark matter, which no one can see. These two types of matter are very different in how they act, how we notice them, and what they can do. Regular matter is the type we know best, while dark matter is still a big mystery. Everything you can see or touch is made of regular matter. The ground, water, clouds, animals, your own body, trees, the moon, the sun, and all the stars, these are all made of regular matter. This matter is made from tiny parts called atoms. Atoms join together to make everything solid, liquid, or gas. With regular matter, you can tell when it is there. You can see it with your eyes, or you can see it in a photo. Regular matter can make light, it can reflect light, and it can block light. If you stand in front of a lamp, you make a shadow. That shadow happens because your body, made of regular matter, blocks some of the lamp's light. When something burns or heats up, like a piece of wood in fire, it gives off heat and light. These are signs that regular matter is present. Dark matter is not like this at all. Dark matter does not make light, it does not reflect light, and it does not block light. No normal camera can take its picture, and you cannot see it with your eyes, no matter how hard you try. If dark matter is all around you, you would never know just by looking or feeling. Dark matter does not make heat or cold, and you cannot taste, smell, or hear it. It is completely quiet and invisible to everything except special experiments. Even though the two kinds of matter are so different, both regular matter and dark matter have something called mass. Mass is what lets matter pull on other things with gravity. When you stand on Earth, you feel heavy because Earth has a lot of mass. The moon goes around Earth because of gravity, and the same goes for the planets going around the sun. Regular matter has mass, and so does dark matter. In this one way, they are alike. Both kinds of matter can pull on other things and make gravity. The mass of regular matter is easy to see. If you put a glass on a scale, you can know how much mass it has. If you pile up bricks, you can feel how much heavier the pile gets. On Earth, regular matter is everywhere around us, and we use it every day. You can build with it, eat it, grow it, or break it apart. It is active in every part of daily life. Dark matter, on the other hand, is not something you can pick up or weigh in an easy way. It does not mix with regular matter, and it does not stop you from doing anything. It passes through everything, walls, stones, your own body, without stopping. But even if it does not stop or slow down for regular matter, dark matter still pulls things with gravity. It has mass, and this mass does important things in the universe. This is how scientists know dark matter is there. They look at the way stars move or the way galaxies spin, and they see more gravity than regular matter can make. This extra pull is because dark matter is present, even if we cannot see it. When you look at the sky, everything you can see, like planets, stars, and dust, is only a very small part of all the matter in the universe. Most of the mass in space is made of dark matter, not regular matter. Scientists have carefully measured the stars, planets, and all the gas in space, and they found that all this is not enough to explain the way things move. The galaxies spin too quickly and stay together better than they should if there were only regular matter. This is why scientists think dark matter is at least 5 or 6 times more common than regular matter in space. Regular matter interacts in many ways besides gravity. It can feel forces like electricity and magnetism. For example, a magnet pulls a piece of metal because both are made of regular matter that can react to those forces. You can rub a balloon on your hair and make it stand up because of electric charge. Regular matter can also combine in many ways to make different things like water, wood, or glass. It can heat up, cool down, melt, boil, or freeze. You can see regular matter change color, shape, or size. All of these actions and changes are only possible with regular matter. Dark matter is very quiet compared to this. It does not feel forces like electricity or magnetism. It does not stick to things, and it does not make sparks or warmth. Even if a huge cloud of dark matter passed through you, you would not notice it at all. Scientists have tried hard to find any sign that dark matter does things with regular matter, but all the tests have shown nothing. Dark matter is only known to pull with gravity, and it keeps to itself in every other way. This is one of the biggest mysteries. Why does dark matter not interact with regular matter in any way we can feel, see, or measure? Regular matter can be part of life. Every living thing is made of regular matter, cells, water, energy, and more. Plants use light to grow, and people use food for their bodies. All of this happens through regular matter and with help from light, heat, and other forces. With dark matter, there is no sign that it is part of life at all. It does not help plants grow, it does not break down into smaller parts, and it is not used by any animal or machine. It just floats in space, doing nothing but pulling with gravity. One important thing about regular matter is that it can join into atoms and then into more complex things, like molecules and big objects. Atoms make up everything that has a hard, soft, or liquid form. You can break a stick, melt ice, or cut a piece of fruit, all because of regular matter's features. Scientists have tools that can show every part of an atom, every move of particles, and every kind of molecule. They know a lot about how regular matter works because it can be studied, touched, or changed. But dark matter does not join to make atoms or molecules. It does not build up into things you can break apart or use in any machine. It does not make clouds, drops, or dust. It is just there, spread out in space without any clear shape or change. Scientists believe that maybe dark matter is made of very small particles, smaller than atoms, but these are not like the ones that make regular matter. Scientists do not know what these particles are because no one has detected them or seen them directly. Regular matter can be hot or cold, and it can change temperature by holding or losing energy. When you heat water, it gets hotter until it boils. When you put something in the freezer, it gets cold and then icy. With dark matter, there is no sign that it gains or loses heat at all. If dark matter passes through a star or a planet, it does not get hotter, colder, softer, or harder. It just keeps moving as if nothing else is there. Another big difference between regular matter and dark matter is how they behave in space. Regular matter can come together to make things, stick to other regular matter, or break apart when it bumps into something else. In space, regular matter gathers and makes clouds, planets, and stars. But if clouds of dark matter move through each other, they do not combine, stick, or break. They simply pass through, showing no sign they even noticed each other. You might think of how regular matter fills your world in every way. Water flows in rivers and oceans. Air fills the sky with clouds. Rocks make up mountains and sand makes up beaches. All these different things are just regular matter in different forms and mixes. In space, regular matter makes stars shine, planets turn, and comets fly. Dark matter is not seen in any normal place on Earth. It does not join the water, clouds, rocks, or air. Even though scientists think dark matter moves through Earth all the time, it is never caught or held by anything. It leaves no mark, no trace, and no change you can find in daily life. Only in the deepest parts of space do we see its effect. The effect is strong enough to keep whole galaxies together with its gravity. When scientists look deeper, they find another reason why regular matter is special. It can be changed into energy or light. In the sun, atoms join in a reaction that makes a lot of energy and light. This is why the sun shines. In machines, regular matter can be changed to heat, light, or movement. This is how you use gas for a car or electricity for a computer. Regular matter gives us power, warmth, and light. Dark matter has never shown any of these signs. It does not change into energy, light, or heat. No scientist has ever found dark matter changing itself or normal matter in any way that gives off energy we can measure. Dark matter just stays quiet and hidden, showing itself only by its pull. Scientists use special experiments to try to find out if there is any small way dark matter could interact with regular matter. They build detectors deep under the ground, away from noise and other regular matter. They wait for months or years, hoping that maybe one piece of dark matter will hit a regular matter particle and make a tiny signal. Sometimes scientists look in space to see if dark matter might break apart or change and make a sign, but nothing clear has been seen yet. Even though the two types of matter are so strange from one another, both regular matter and dark matter are needed for the universe to be the way it is. The glowing stars, the spinning galaxies, and the way everything moves in the sky all are shaped by the mix of regular matter and dark matter. Without regular matter, there would be no planets, no life, no light, and no color. Without dark matter, there would not be enough gravity to hold galaxies together and help them form. In the biggest picture, regular matter gives us everything we see, feel, and use, while dark matter shapes where regular matter can gather and how it can form big objects in space. When you look at everything that is close by, it is regular matter. When you think about what keeps everything together and how things move in the largest parts of space, that is where dark matter's gravity is at work. By learning about both regular matter and dark matter, scientists hope to answer many big questions. Why does dark matter have so much mass but stay invisible? How does regular matter give us life, energy, and light, while dark matter does none of these? Scientists want to learn not just what they are, but why there are two types at all. With each new experiment and observation in space, people learn a little more, and the mystery of dark matter becomes both bigger and more interesting. The journey to understand these differences touches on what makes up all of space, how stars and galaxies grow, and why the universe looks the way it does. Both types of matter, one that we know well and one that is still mostly unknown, work together to shape everything that exists. Through their gravity, they control the movements of stars, planets, and galaxies. But one remains close and familiar, while the other is silent, hidden, and waiting to be better understood. Scientists have been very curious about the things they see in the universe. A long time ago, people looked at the sky and tried to understand how stars move. When telescopes were invented, people could see much more. Little by little, more details about the sky became clear. As people learned more, they noticed that stars and galaxies did not always move in ways that made sense. Some movements seemed strange, and regular matter was not enough to explain everything that was happening far away in space. As scientists kept studying space, they began to notice some patterns. When they watched how stars spun around in their galaxies, they expected those stars to move slowly at the edges. The idea was simple. If regular matter was the only thing present, faraway stars should move slower because there is not much mass to pull them in the outer parts. But when scientists measured their speed, they were surprised. The stars at the edges of galaxies were moving much faster than they should. It was as if something extra was pulling them, keeping them from flying away. This discovery puzzled many people who studied the universe. They tried their best to make these movements fit with what was seen. Some scientists checked all the regular matter they could find, like stars, gas, and dust in each galaxy. But there was just not enough. Even after counting everything visible, something was still missing. The gravity from regular matter could not explain what was happening. People started to ask new questions. Why do whole galaxies keep their shape? Why don't the stars fly off into space? Why do galaxies turn the way they do? The answer seemed to be that there must be something else in these galaxies. There must be more matter that we cannot see. That was when the idea of dark matter started to become important. One scientist who helped bring this mystery into focus was Vera Rubin. In the 1960s and 1970s, she used telescopes to watch many different galaxies. She spent years measuring how fast the stars went around the center of each galaxy. Vera Rubin and her team collected lots of data. Every time, the results were the same. The outer stars were moving too fast. There was not enough regular matter to hold these stars in place. Vera Rubin's work showed the problem was everywhere, not just in one or two galaxies. Other scientists looked closer at groups of galaxies called galaxy clusters. These are large areas where many galaxies travel together. A scientist named Fritz Zwicky had already noticed in the 1930s that galaxies in clusters moved in ways that could not be explained by the matter you can see. He used the word dunkle materie, which means dark matter, to describe this extra invisible stuff. He said it was dark because nobody could see it, yet it seemed to be holding the galaxy clusters together. At first, not everyone believed that dark matter was real. Some thought maybe the way we understand gravity is not correct when looking at big distances. Some thought there could be mistakes in the way the data was measured. But as more people did their own studies, they kept finding the same problem. No matter how much regular matter was counted, it was never enough. The case for dark matter became stronger as better telescopes and computers arrived. More data was collected from more galaxies and clusters. Each time a galaxy's rotation was measured, the answer was always missing mass. The only way to explain the fast spinning of galaxies and the tight shape of galaxy clusters was to have something more, something that did not give off any light. This was what scientists started to call dark matter. It became clear that the universe had to be filled with something invisible that could pull on regular matter with gravity. As computer models improved, scientists did more tests. They made maps to show all the mass in different parts of the universe. These maps needed extra matter to match what is actually seen. When computer models used only regular matter, galaxies would fall apart in the simulation. But when extra invisible matter was added, the galaxies acted the same way as real galaxies in the sky. Scientists have also used large surveys of space to look for hints of dark matter. They measured the light from millions of galaxies. In every survey, the same pattern showed up. The shapes and movements could only be explained with the help of something hidden. Regular matter could show where the stars and planets were, but the biggest part was always missing from the picture. There are other reasons why scientists believe dark matter is real. Sometimes two galaxies crash into each other and merge, making a big jumble of stars and gas. When these crashes are studied, scientists see that most of the matter does not behave like regular matter. If only regular matter were present, all the mass and gas would pile up in the middle. But special measurements show that a lot of mass stays away from the crash, as if it is not affected by the crash at all. Regular matter slows down and heats up, but the hidden part, which must be dark matter, does not slow down. A famous study called the Bullet Cluster helped show this. In this group of colliding galaxies, scientists saw that regular matter, like hot gas, stayed in one place, but the center of mass, measured by its gravity, was around the stars that kept moving through each other. This meant that there had to be something with mass that did not crash or heat up, something that just kept going. This was more proof that dark matter was real and did not interact with regular matter in the same way. Even when scientists studied the oldest light in the universe, called the cosmic microwave background, they found more reasons to believe in dark matter. This light is a kind of glow left over from just after the universe began, almost 14 billion years ago. It has tiny spots of hotter or colder light that show where matter was packed or spread out. Scientists looked at these patterns very closely. Their studies showed that the early universe needed much more mass than just regular matter. Without this extra mass, the patterns in the cosmic light would not look the way they do. These different clues all suggest the same answer. Galaxies, clusters, and even the oldest light in the universe show there is more mass than what we can see. The only way to make sense of all this is by saying that most of the matter in space is dark matter. Even though the case for dark matter is strong, scientists still keep testing their ideas. They look for ways to be sure that dark matter really exists. They try to find other possible causes or to check if our understanding of gravity changes at very great distances. However, so far, no other ideas explain everything as well as dark matter does. When scientists put all the pieces together, the discovery of dark matter shows how careful study and questioning can lead to new and surprising answers. At first, it seemed like there was a problem with how things moved in space, but after many years and many tests, a new picture came into view. The universe is not just what we see. Most of it is made of something invisible, something that pulls with gravity but does not shine or block any light. This discovery changed the way we think about everything in the universe. It showed that there is still so much to learn. The idea of dark matter opened many new questions. Where does it come from? How much of it is there? What is it made of? Why does it not interact with regular matter in more ways? Scientists around the world work every day to try to find answers. New machines and tools help scientists get better data. Telescopes now look with more detail at the sky than ever before. Computers can run very complicated models to show what happens when dark matter is added to galaxies and clusters. Each year, scientists learn a little more, but the puzzle of dark matter is still not solved. As discoveries about dark matter continue, its importance for the understanding of the universe grows. When scientists look at the movements of all the stars in a galaxy, they always find that invisible matter is needed. When they look at clusters of galaxies, dark matter is always needed. Even when looking at the biggest map of the universe, showing where every galaxy is, the pattern fits only if there is much more mass than we can see. Every part of science uses questions, tests, and new ideas. The story of how dark matter was discovered is an example of how careful work can change what we know about everything around us. Today, science knows that regular matter is only a small part of what fills the universe. The rest is dark matter, quiet, hidden, but very important. By searching for answers about how galaxies and stars move, we have found that the universe is much stranger and bigger than we first thought. The curious movements of stars and galaxies were the first sign. The careful tracking of their speed, the study of galaxy clusters, the clues in the oldest light, and the strange results from galaxy crashes all built a strong case. Together, all this work points to dark matter as the main part of the universe's mass, something that is always there, even if we never see it with our own eyes. Learning about how dark matter was discovered helps us understand why scientists are so sure there is something more out in space. From the movement of stars, to the giant shapes in the sky, to the patterns of light from the very start of time, every sign shows that dark matter must exist. The job now is to learn what dark matter really is, how it works, and how its gravity shapes everything that we can see. Each new piece of evidence leads to more questions and helps everyone who studies the universe hope they will someday solve the mystery of this important and invisible matter. Gravity is one of the most important forces in the universe. It affects everything that has mass, no matter how small or large. When people first began to understand the movement of objects in space, they learned that gravity pulls things toward each other. It is the reason why the planets move around the sun. It is why stars stay together in groups called galaxies. Gravity is also the reason why we stand on the ground and why objects fall when we drop them. Everything with mass makes gravity. The more mass something has, the stronger its gravity. When gazing at the universe, it is clear that gravity shapes almost everything. Regular matter, like stars, planets, and gas, has mass. This mass creates gravity and pulls other things closer. But dark matter, even though we cannot see it, also has mass. Dark matter makes gravity as well, and this gravity is just as real as the gravity from regular matter. The difference is that, while regular matter does many things, like shining, reflecting, or blocking light, dark matter only shows itself through gravity. There is no other sign. This makes gravity very important for finding and understanding dark matter. In a galaxy, there are hundreds of billions of stars and even more particles of gas and dust. The visible mass from the stars and gas should create a certain amount of gravity. Scientists can add all of this together and figure out how strong the gravity from regular matter would be. When they measure how fast stars move around the center of a galaxy, those speeds are much higher than expected. This tells us there must be more gravity in the galaxy than just from what we can see. The extra gravity is caused by dark matter. Galaxies also have certain shapes because of gravity. Stars are spread out in a flat disk, while the middle of the galaxy is thick and bright because there is so much mass there. The stars in the middle move very quickly, and stars at the edge move quickly too. Scientists use large telescopes to measure these movements, and with every galaxy they study, the same result is found. Not enough mass can be seen to explain the gravity holding everything in place. The only way to explain this is to understand that there is more mass in the galaxy that we cannot see. This hidden mass is dark matter. Not only do individual galaxies need dark matter, but groups of galaxies also need it to stay together. These groups are called galaxy clusters. A cluster has many galaxies in it. Their combined mass should give a certain amount of gravity. When scientists observe how these galaxies move inside the cluster, they see that the movements are much faster than can be explained by the stars and gas alone. If there was not extra gravity, the galaxies would drift away from the cluster, but they stay together. The gravity is strong enough to hold the whole cluster thanks to dark matter's mass. Gravity has no color, no shape, and no taste. You cannot see it or touch it directly, but you can see what it does. You see its effect whenever something falls or whenever the moon moves through the sky. On Earth, gravity keeps everything on the ground. In space, gravity holds stars and planets in place. Dark matter's gravity does the same, but you cannot see the matter itself. You only see the movement or the shape that happens because gravity is present. One very important idea is that gravity affects both regular matter and dark matter. If there is a lot of dark matter in an area, its gravity pulls regular matter toward it. Over long times, this can gather together huge clouds of gas and dust where stars are later born. In the early universe, just after the beginning of time, dark matter was already present. Its gravity helped regular matter clump together and form the first galaxies. Without dark matter, it would have taken much longer for regular matter to come together and make stars and galaxies. Many scientists believe that galaxies might not have formed at all if dark matter was missing. The universe would look very different and much emptier without the gravity from dark matter. The way gravity works is always the same, wherever you are. If you double the mass, you double the gravity. If you move farther from the mass, the gravity gets weaker. These are simple rules, and scientists have tested them for hundreds of years. These rules also help in making maps of galaxies and their movements. When the rules say there should be less gravity than what is measured, it means there is more mass in the area. Scientists look for dark matter wherever there is more gravity than regular matter can provide. Dark matter does not gather at the surface of planets or shine like stars, but it fills huge, invisible halos around galaxies. These halos are like giant clouds of mass that go far beyond where the stars end. Most of the mass in a galaxy is not in the part that shines. It is in this dark halo. Without the halo, the gravity would be too weak to keep all the stars moving together. Scientists have found that the size of these halos can be many times bigger than the visible part of the galaxy. Sometimes the dark matter halo is at least 10 times wider than the circle of bright stars. By looking at the shapes of galaxies and the way they move, scientists are able to draw maps showing where regular matter and dark matter are found. The regular matter is always the part that is bright or that gives off light. The dark matter is always invisible, but its effect is clear through its gravity. The gravity of dark matter pulls gas into the center of a galaxy and helps stars form faster. It also keeps the stars from flying away when they spin around the center. Even small galaxies called dwarf galaxies need dark matter to explain how their stars move. These little galaxies have much less light and mass than big galaxies. Still, they spin fast and do not break apart, even though they have little visible matter. The only answer is that each small galaxy also has a large amount of dark matter in a halo around it. In all types of galaxies, dark matter controls the way things move by its gravity. The universe is very large, and gravity is what connects everything. There are millions of galaxies, and each one can have trillions of stars. All of this is held together by gravity, both from regular matter and from dark matter. Gravity helps shape the biggest structures that exist. Even groups of clusters can form, connected by long lines and walls of galaxies. These even larger structures, sometimes called superclusters, are built with the help of dark matter's gravity. On smaller scales, gravity brings together gas and dust so new stars can be born. When enough mass comes together, its gravity can crush the gas until the center becomes hot. Then a star lights up and shines. This process happens again and again, making many stars in a galaxy, all helped by the pull of dark matter. Every time a new star forms, it is because gravity brought regular matter together. In the beginning, it was the gravity of dark matter that started this clumping in the first place. Gravity also ties together events far away in time. The very first galaxies in the universe needed the gravity from dark matter to form. Over billions of years, this gravity has kept the galaxies together, stopping them from falling apart. It is this silent effect that tells scientists that dark matter is everywhere. Sometimes, gravity creates special shapes and effects that scientists can measure. For example, if there is a lot of mass in one spot, light that passes nearby can be bent. This happens with regular matter, and it happens with dark matter too. This bending of light is called gravitational lensing. When scientists see that light from behind a galaxy is bent more than it should be, this is another clue that dark matter must be present. The more the light bends, the more mass there must be in the way, even if we cannot see it. Scientists use the effect of gravity to learn about dark matter and to make maps of where it might be found in the universe. They look for the ways gravity affects stars, gas, galaxies, and light. When something is not moving as expected, or when light bends more than it should, scientists know that dark matter is at work. By adding up all of these clues, they can guess how much dark matter there is and where it is hiding. Gravity does not just keep things together, it also controls how things move. It tells a planet how to orbit a star, how a star moves around the center of a galaxy, and how galaxies spin inside a cluster. Every time scientists see something moving at a speed that regular matter cannot explain, they look for dark matter's gravity as the missing piece of the puzzle. In this way, gravity lets us find the invisible, even though we can never see it directly. Scientists have made many tests and used many kinds of data to be sure about the role of gravity and dark matter. They have measured the motions of stars in our galaxy. They have looked at hundreds or thousands of galaxies in other groups. They have watched the light from behind galaxies bend and curve. All of these tests give the same answer. There is always more gravity than should be possible from the regular matter seen. The study of gravity also gives hints about how much dark matter must be in the universe. By counting the fast movements and by how much light bends, scientists can measure the amount of extra mass. Their studies show that dark matter must be about 5 times more common than regular matter. That means, for every part of regular matter, there are 5 parts of dark matter, all working through their gravity. This explains why dark matter's gravity is so important to galaxies, clusters, and the whole universe. There are many special tools scientists use to follow how gravity acts. With space telescopes, they can watch the movement of stars and galaxies with great care. Computers help make models that test what will happen if more or less dark matter is in an area. By changing the amount of dark matter in these models, scientists can make the galaxies in the model act just like real ones. This is more proof that gravity from dark matter is real and necessary. Over time, the understanding of gravity has helped to show just how much of the universe is unseen. gravity is the one way we can know dark matter is there. By looking at what gravity does, scientists have been able to find the hidden halos, explain the shapes of galaxies, and understand the groups and clusters that fill the universe. The secret story of dark matter is written in the movements and shapes that gravity creates. Without this silent force, the universe would be a very different place. There would be fewer galaxies, and they would not be able to hold together for long. But with the hidden mass of dark matter, gravity is strong enough to let galaxies, clusters, and superclusters stay together for billions of years. Gravity's rules never change, and they affect everything with mass, whether it can be seen or not. Scientists keep searching for more details about dark matter by following the work of gravity all across space. This work helps to answer many deep questions about how the universe came to be and why it looks the way it does. When we look at the wonders of the universe, we know that gravity controls them all. Regular matter shines, gives warmth, and can be touched, but dark matter does its important work in the shadows, moving only through gravity. All the stars we see, all the galaxies in the sky, and all the biggest shapes in space are possible because gravity binds both regular matter and dark matter together. This silent partnership has shaped the universe from the very beginning until now, and it continues its work far into the future. The invisible work of gravity from dark matter not only holds galaxies and clusters together, but it also affects light as it travels through space. Light, which moves in straight lines in empty space, can be pulled by gravity when it passes near a very large amount of mass. This happens for both regular matter and dark matter. The more mass that is present, the stronger the pull on the light. This pulling of light by gravity changes the direction in which the light travels. This change is called gravitational lensing. Gravitational lensing is a very important clue that shows dark matter is real, even though it cannot be seen directly. When light from stars or entire galaxies travels toward us, it sometimes passes near or through places where there is a large amount of mass. That mass can be regular matter, like a group of galaxies, or it can be a mix of regular matter and dark matter. Because dark matter does not shine or block light, scientists cannot see it in a picture, but its mass still bends the light. Gravitational lensing makes distant objects look different. Sometimes, an object that is far away looks brighter, bigger, or stretched into strange shapes. This strange effect happens because the path of the light has been bent as it travels past things with lots of mass. Sometimes, the light even makes more than one image of the same faraway object appear on the sky, showing up as two or more spots. Scientists use telescopes to study these special shapes and patterns in the sky. When they find a galaxy or a cluster that bends the light from objects behind it, they can measure how much the light bends. By doing this, they can figure out how much mass is causing the bending. Many times, scientists find that there is much more mass than what they can see with their eyes or with computers that count stars and gas. This hidden mass is dark matter. There are two main types of gravitational lensing. The first type is called strong lensing. In strong lensing, the mass is so great that it bends the light a lot. This can create shapes like rings, arcs, or multiple images. When telescopes see these patterns, scientists know a lot of mass is found in a very small area. Strong lensing is used to study the centers of clusters of galaxies, where a huge amount of regular matter and dark matter come together. The second type is called weak lensing. In weak lensing, the effect is not as strong, but it still stretches and changes the shape of light from very distant galaxies. Instead of making big rings or arcs, weak lensing makes background galaxies look a little bit longer or squeezed in a certain direction. By looking at the way many galaxies are changed, scientists can create a map of where mass is found in the universe, even when most of it is invisible dark matter. Gravitational lensing is one of the strongest pieces of evidence for dark matter. Over the last several decades, scientists have looked at many clusters of galaxies using telescopes on the ground and in space. They measured the light bending in many places. Every time, the amount of bending was too great to be explained by regular matter alone. There was always extra mass needed to match the lensing seen in the images. This extra is always dark matter, which does not make or block light, but pulls on it with gravity. When scientists use gravitational lensing to map out the mass in clusters, they find that the map of mass does not match the map of light. In these areas, most of the mass is invisible. The mass follows the shape of the cluster, but it does not shine. This is more proof that something big but invisible, something with mass but no light, fills much of space. This something is dark matter. In one very famous example, the Bullet Cluster, two groups of galaxies have passed through each other in space. When scientists studied the Bullet Cluster, they found that most of the hot gas, made of regular matter, was pushed to the side, but the mass measured by gravitational lensing did not move as much. This mass stayed with the galaxies, following a different path than the visible gas. Scientists measured where most of the gravity or mass really was, and it was in a place with little regular matter. The only way to explain this is with dark matter. The dark matter kept moving even when the gas was stopped. Gravitational lensing can be seen in many different systems. Galaxies can be lenses when they are between us and something else in the background. Large clusters are even stronger lenses. Even very small, very far away galaxies can change the light from things behind them. With every new observation, scientists find more proof that dark matter is everywhere, shaping the sky. The ability to map dark matter with light bending is very powerful. Scientists use computers to look at thousands or millions of galaxies and watch for how their shapes are changed. From this, they can draw maps of mass over large parts of the universe. These maps show that dark matter makes huge, invisible webs that connect clusters and galaxies. Ordinary matter is just the small part of these webs that can be seen. These tests always show there is 5 times more mass in dark matter than in regular matter. Gravitational lensing also helps scientists learn more about how dark matter is spread throughout a galaxy. In a large spiral galaxy, the visible stars and gas are only a small part of its total mass. Lensing shows that much more mass surrounds the visible part in a shape called a halo. This halo of dark matter goes far out into space, well beyond where the last stars shine. The gravity from this halo does not make any light, but it is there every time scientists use lensing to check. Not only does gravitational lensing tell us where dark matter is, it also tells us how much is present everywhere in space. When scientists look at lensing across huge areas of the sky, they see that dark matter makes up the largest part of all the mass in the universe. Without this dark matter, there would not be enough gravity to bend the light as much as is seen. The large arcs, rings, and strange shapes could not happen without it. By measuring the amount of lensing, scientists can even learn about how dark matter slowed down or helped form structures in the past. Looking at very faraway places is like looking back in time, because the light has taken many billions of years to travel to us. The oldest clusters, the oldest galaxies, and the earliest signs of structure all have dark matter present in the right amounts. These results match the idea that dark matter has always been part of the universe, shaping how galaxies and clusters grow. Gravitational lensing helps scientists test their ideas about dark matter in other ways too. Some scientists wonder if there could be another reason for the extra gravity that is seen. But the patterns of lensing are very exact. If there were something wrong with how gravity works, the lensing would not happen the same way over large areas. The fact that lensing always points to invisible mass is more proof that dark matter is real and everywhere. Scientists also use lensing to look for other possible types of dark matter. Some models say dark matter might be made of very small, very dense objects. Others say dark matter is in the form of a new kind of particle that is spread all over. When scientists look at the shapes and amounts of lensing, they can test these models. So far, the data matches best with dark matter being in the form of invisible particles that only pull with gravity, never shining or blocking light. With gravitational lensing, scientists can study parts of the universe that are very far away. They can look deep in space, to galaxies and clusters that are almost at the edge of what can be seen. Lensing lets scientists learn about dark matter everywhere, not just close by. It is a tool that works with tiny galaxies, massive clusters, and even the largest structures in space. The bending of light gives scientists a new way to look at things that cannot be seen directly. By gathering information from gravitational lensing, scientists improve their maps of where all the matter is, regular and dark. These maps help explain how galaxies form, why clusters have the shapes they do, and how the universe has grown over time. Each new lensing study adds more detail to our picture of dark matter. The shapes, patterns, and sizes of what is seen all match with the idea that the universe is mostly made of this hidden, invisible mass. One more important use for gravitational lensing is that it teaches scientists about the small changes or ripples that are present in the universe. Tiny changes in how mass is spread out can make light bend in different ways. By carefully looking at these little changes, scientists learn about how dark matter collects in small spots as well as big ones. This level of detail helps test new theories about what dark matter is and how it behaves. Every time a telescope takes a deeper picture of space, it gives a chance to see more lensing. Scientists always prepare new tools and better ways to look at the sky because they want to make the most detailed maps they can. By making these maps better, they hope to learn even more about dark matter. These pictures will help answer some of the biggest questions, like why the universe has the shape it has and how it continues to grow. In space, light takes a very long time to travel from far away to us. The older the light, the farther back in time we can see. Gravitational lensing lets scientists look back through many billions of years to the earliest times. By seeing the way light is bent in faraway places, they know that dark matter has been important since the very beginning. Its gravity shaped the first galaxies and has carried on shaping the universe as it became bigger and more filled with stars, planets, and life. Even though dark matter cannot be seen, its presence is clear in every map of lensing. The results are always the same. Galaxies and clusters are much heavier than they look, with most of their mass hidden from sight. Lensing shows this to us over and over again in every place scientists look. This is strong evidence that dark matter is real throughout all of space. By following the path of light, scientists learn about places they can never reach by traveling. Gravitational lensing is like a tool that opens a window through space and time, letting people study things that would otherwise stay forever hidden. The bending light marks the hidden hand of dark matter all around us. This process allows scientists to study the invisible, to measure the mass that gives no light and makes no sound, but that still shapes the biggest and smallest parts of the universe. The search continues for new and better ways to see the effects of dark matter. Telescopes become stronger, computers become faster, and more people work together from all around the world. Each new chart, each new discovery helps reveal a little more of the hidden parts of the universe. With gravitational lensing, the invisible becomes known, and the mysteries of dark matter become just a little bit clearer for everyone who is searching for answers. When scientists use the patterns of light bending across the sky to find dark matter, they often ask themselves a very big question. They want to know what dark matter really is. It is clear that dark matter does not make light or block light. It pulls with gravity, and it helps shape the universe, but it stays hidden in every other way. This has led people in science to wonder about what dark matter could be made of. If it is not like stars, planets, or gas, and if it cannot be touched or held, then what is it? Scientists think that all regular matter is made of very small pieces called atoms. These atoms join together to create everything around us. Atoms have tiny parts inside them called protons, neutrons, and electrons. These are the pieces that build up all regular matter, from the smallest speck of dust to the biggest star. Regular matter can make chemical reactions. It can give off heat and light, and it can be touched in many ways. Scientists know how to study atoms and all their parts with special machines and tools, and they can see how these things change and behave. But dark matter cannot be made of the atoms that build normal things. If it were made of atoms, dark matter would shine in some way, block light, or take part in chemical bonds. It would act like normal matter sometimes. But scientists do not see this happen, even when they look very closely. Dark matter passes through everything and does not make, reflect, or block any light. It does not break apart, mix, or make heat the way regular matter does. Because of this, dark matter must be made of something that is not like atoms at all. To answer what makes up dark matter, scientists have many ideas, but they do not have a final answer yet. Most believe dark matter is made of very tiny particles. These particles are even smaller than atoms or protons. They are things that do not interact with regular matter, except through gravity. These particles do not have electric charge. They do not feel the forces that allow atoms and light to interact. Almost all the time, they move through regular matter without touching or being stopped. One idea is that dark matter could be made of something called WIMPs. WIMP stands for Weakly Interacting Massive Particles. The name means that these particles have mass, so they make gravity, but they do not interact strongly with regular matter or light. They move through regular matter without being stopped. If WIMPs exist, they could fill up all the dark matter in the universe, and scientists think there could be a large number of them everywhere. Another idea is that dark matter could be made of things called axions. Axions are even lighter and smaller than WIMPs. They are expected to have no electric charge and would not give off light or energy. Axions would fill the universe but would be very hard to see because they never interact with regular matter except through gravity and maybe in other tiny, weak ways. Up until now, axions have not been found, but scientists are always looking for them. Some scientists have thought that dark matter could be made of things like black holes or failed stars that do not give off much light. These objects, if they are small and cold, would be very hard to see. However, studies have shown that there are not enough black holes or failed stars to make up all the dark matter in the universe. Most of the mass must come from another source, something more common and invisible. People also wonder if there are other kinds of tiny particles that could be responsible for dark matter. The world of particles is full of many strange options. Each time scientists test new theories with experiments, they hope to find a sign from one of these tiny things. So far, none of the searches have given a clear answer. Dark matter stays hidden. No matter which type of particle it is, dark matter must have certain behaviors. It must pull with gravity. It must not take part in light or heat or make chemical bonds. It must pass through regular matter easily and not show up in other ways that we can see. Its particles must have been made very early in the history of the universe. From the study of the oldest light, called the cosmic microwave background, scientists know that dark matter was already present soon after the universe began, many billions of years ago. It was there before stars or galaxies, pulling regular matter to make the first clumps of gas and starting the process that made galaxies. Some people ask if dark matter could be made of neutrinos. Neutrinos are very tiny particles that are made during nuclear reactions, like in the Sun. Neutrinos are almost impossible to see, but they have a very small mass. At first, scientists thought maybe all the dark matter could be made of neutrinos, but neutrinos move very quickly and they do not gather in one place easily. Studies have shown that if all the dark matter was made of neutrinos, galaxies and clusters would not have the shapes we see. So neutrinos can only be a very small part of dark matter, not all of it. To decide which particles dark matter is made of, scientists look for ways to find a signal. If a WIMP hits a regular atom, it might make a tiny impact that machines could detect. If an axion moves through a certain field, it might make a very weak signal that scientists can look for. To test these ideas, scientists have built experiments deep underground, away from other things that can make noise or confusion. They wait for long times, hoping that one dark matter particle might touch their machine. Some experiments use large tanks of very pure liquid, like liquid xenon, or crystals that can make a small flash of light if hit. There are also experiments that look for tiny waves made by axions. Other scientists use telescopes to study the sky for special types of light or changes that might happen when particles of dark matter bump into each other or break apart. So far, no experiment has found clear, direct proof of any of these particles. The search goes on year after year. At the same time, computers help scientists to think about what the universe would look like with different types of dark matter. If the particles are heavy, gravity will pull them into clumps quickly. If the particles are light, they will not gather together easily. The best computer models match the idea that dark matter is cold, which means it moves slowly enough to make big clumps that form galaxies and clusters. Another important rule is that dark matter cannot lose much energy. If it did, it would fall toward the middle of a galaxy or cluster and mix with regular matter, but scientists do not see this happen. Instead, dark matter is always spread out, making big halos around galaxies. This tells us that whatever it is made of, it cannot be something that easily loses energy, like regular matter does. Some scientists think that dark matter could be a new type of particle that has not yet been found in any experiment. There are ideas from math and physics that predict many more particles than are known now. Maybe one of these will be the true source of dark matter. It could take years or even decades to find the answer, but scientists continue spending time, money, and effort in the hope of learning what this invisible matter is made of. Dark matter is also not seen in any of the ways regular matter is. It is not part of the air or water, not in rocks, not in sunlight, and not part of the atoms that make up people, plants, or animals. It does not affect radio waves, X-rays, or microwaves. All of the normal signals that scientists can send or receive show no sign of dark matter, only its gravity. This makes the job of finding it even harder. Every time a new particle is found, scientists hope it might be the piece that solves the puzzle. But so far, each new discovery has shown that particle to be a form of regular matter or something already known. None of these has explained the mass and the behavior needed for dark matter. The universe keeps its secret. Scientists also check if maybe dark matter is made of many types of particles, not just one. It is possible the universe holds more surprises and that more than one kind of invisible particle is responsible for the gravity we see. If that is true, the search could become even more complicated with several new ideas to check. Many groups of scientists from different countries work together. They build more sensitive detectors, make better computer models, and invent new ways to look for signs. They share their data and test each other's findings to avoid mistakes. The hope is that with teamwork, a signal will appear that points to the exact nature of dark matter. Big questions remain open. Why is dark matter so common but so hard to find? Why does it have gravity but not take part in the other forces of nature? Was it made during the beginning of the universe, or does it come from something else? Could there be a hidden part of physics that we have not recorded or measured yet? Some scientists look at the sky for signs that dark matter might interact with itself or with regular matter in a very rare way. They search for small explosions or flashes in very empty places in space. These flashes could be the result of dark matter particles meeting and changing into other particles. Up to now, no clear sign has been found. Many discoveries in science take a very long time. Sometimes it takes years, sometimes hundreds of years for the tools and experiments to become good enough. Even without the answer, each experiment teaches scientists something new about the universe and about how to search for invisible things. Every failed test rules out one idea, which helps focus the next steps. The next discoveries could come from bigger telescopes, stronger detectors, or smarter experiments with computers. The search for what dark matter is made of is one of the main goals of modern science. Because dark matter is everywhere, it is one of the big keys to understanding why the universe is shaped as it is, why galaxies stand together, and why stars and planets have formed over so many billions of years. As more knowledge is gained, scientists get closer to being able to explain everything that exists, not just the part of the universe that shines, but also the quiet, hidden part that holds it all together. By following clues, making new ideas, and working together, the hope is that soon the true nature of dark matter will become clear for everyone. Every experiment, every piece of data, and every observation keeps science moving step by step, closer to the answer to one of the universe's greatest mysteries. Understanding what dark matter is made of is very hard, because nothing in daily life gives a clue, and it does not react with light, heat, or the normal forces that let us touch or measure things. For this reason, scientists who search for dark matter must use very special ways to look for it. They have to use careful thinking, new ideas, and advanced tools. The search for dark matter brings together people from many countries, all hoping to find evidence that shows what this invisible matter is. A main way that scientists look for dark matter is by building strong detectors deep under the ground. These places are far from the noise and changes that happen at the surface of the Earth. The goal is to find a place where nothing else can disturb the experiment. Things like wind, light, radio waves, or electric power can make noise that confuses the results. So underground laboratories are quiet and dark. In these deep places, scientists carefully wait for a sign that a dark matter particle has touched something inside a detector. These detectors are made using very clean and pure substances. Some are filled with liquid xenon, a gas cooled to become a liquid. Others use large blocks of very pure materials like germanium or sodium iodide. These detectors are kept very cold. The idea is that when a dark matter particle moves through the Earth, it might touch an atom in the detector and make a tiny flash of light or a very small change in temperature. The scientists use sensitive machines to watch for any such sign, no matter how small. While they wait, scientists have to check every flash or signal very carefully. There are many things in the world that can make a flash besides dark matter. natural radiation from rocks, tiny particles called neutrinos. Even the smallest amount of dust can make signals. For this reason, every signal must be checked to see if it comes from something known. Only something that cannot be explained by anything else might be proof of dark matter. Up to now, these underground detectors have not found a clear and strong sign that a dark matter particle has hit something inside. Each experiment runs for many years. Every time a new detector is built, it is made bigger, cleaner, and more sensitive than before. As scientists wait for a dark matter particle, they also learn more about the kinds of noise that can confuse a signal. Even negative results help. By not finding a signal, they learn which ideas about dark matter are wrong, and they know how to improve the next test. There are also experiments that use other ways to search for dark matter. One way is to watch the sky with telescopes and detectors on the ground and in space. Some scientists believe that if dark matter particles meet in space, they might destroy each other and give off energy in the form of special signals, like gamma rays or other kinds of light. If this happened, it would be possible to see a tiny burst of light or particles from space that cannot be explained by stars, galaxies, or black holes. Special telescopes look for these kinds of signals all the time. The Fermi Gamma Ray Space Telescope, for example, watched the center of our galaxy to see if there were any signals from dark matter. Other telescopes look for different types of light or for strange particles arriving from far away. These telescopes must carefully remove the effects of all known sources like stars, hot gas, or regular explosions in space. After all of this, the scientists look for leftovers that do not fit anything known. So far, these kinds of telescopes have found some exciting hints, but there is still nothing that is sure proof of dark matter. Sometimes scientists see a signal that might be from dark matter, but later they learn it is caused by another thing, like a group of stars or a new type of explosion in the universe. Because dark matter is so quiet and invisible, it is hard to be certain about any signal. Another approach is to use giant machines called particle colliders. The most famous collider is the Large Hadron Collider, which is in a long tunnel near the border between France and Switzerland. In these machines, scientists make very tiny particles move at almost the speed of light. Then, they make particles crash together in a controlled way. These collisions can make new particles appear, some of which are unknown to science. Scientists carefully look at every result from these crashes. They count all the energy and mass of the things they see. If any energy or mass goes missing in the machine, this could mean that a dark matter particle has been made and then moved away without being seen. The hope is that by making millions of collisions, a sign of dark matter might appear. So far, no clear dark matter particle has been found in these colliders. Each test helps narrow down the choices. Every particle seen so far fits with the regular rules that describe ordinary matter. But the work goes on, and scientists make new changes to the machines to search better. Computers are another tool that scientists use to learn about dark matter. With powerful computers, it is possible to make huge models of how the universe grows and changes. These models can start right after the Big Bang, almost 14 billion years ago, and follow the way regular matter and dark matter move and come together to make galaxies, stars, and clusters. By changing how much dark matter there is in the computer or what it acts like, scientists compare the models to what is really seen in space. If the model makes galaxies or clusters that are too big, too small, or the wrong shape, the scientists know the idea about dark matter must be wrong. These tests help to show that dark matter must be cold, meaning it moves slowly. Cold dark matter helps make the universe we see. These computer tests can also check how dark matter is spread across space. Some models put dark matter in big clumps, while others spread it out. When scientists compare the models to real maps of galaxies as seen by telescopes, they see which matches best. These tests show that dark matter is found in halos around galaxies and in big webs that fill space between clusters. Even the oldest light in the universe, called the cosmic microwave background, gives clues about dark matter. This light comes from a time soon after the universe started, and it carries tiny changes that match how matter was spread out. Scientists look for small spots and lines in this light that tell how much dark matter there was in the past and how it helped pull regular matter together. This makes the study of old light a very good tool because it shows how important dark matter has always been. When scientists use all these tests together, deep underground detectors, space telescopes, computer models, particle colliders, and old light, they start to get many pieces of the puzzle. Each piece must fit with what is seen in nature. If a theory cannot explain how galaxies are held together, how light bends, and how the universe looks, then it must be changed. Some people wonder if dark matter could be seen more easily if it sometimes changed into other forms. Perhaps in very rare cases, dark matter particles could crash and change into regular matter or make a flash of light. If this happens, it would be possible to find a signal, even if the chance is very low. This is another reason why scientists collect huge amounts of data from all over the world and use many different kinds of machines. Some groups carefully watch for special types of particles called axions, which very slowly change into light in a strong magnetic field. These experiments need extra sensitive equipment and a lot of patience, because if axions are real, their effect is very weak. Other groups test the idea that dark matter is made of very heavy, slow-moving particles by building detectors that listen for the smallest sound or heat. When something looks promising, scientists study it for a long time. They check the data many times and ask others for help in finding any mistakes. This careful checking is important so that nothing is announced as proof unless there is strong evidence. Sometimes years pass before a possible signal is understood. Because dark matter does not interact with most things, and because regular matter is everywhere on Earth, finding dark matter is a big challenge. To handle this, scientists work with great care. They check for anything that might be a trick from known sources like natural radioactivity, cosmic rays, or machine noise. They use giant shields, thick walls, and clean rooms for their tests. The most sensitive experiments often have a detector deep inside a mountain or even underwater in an old mine. All these efforts are made to remove all the noise and leave only what could be a signal from dark matter. Scientists in countries all over the world are building new experiments. In Italy, there are detectors under the Gran Sasso mountain. In Canada, there are coal detectors in deep mines. In the United States, the Sanford Underground Research Facility is home to some of the biggest and most sensitive detectors ever built. In China, Japan, and many European countries, new plans are always being made to search for dark matter. All of these experiments keep improving their tools every year. Each version looks for smaller and weaker signals. As scientists get better at this work, they also open the doors to new findings about other things, like the behavior of neutrinos or how regular matter acts when it is very cold or very dense. Testing what dark matter is has also made many other discoveries possible. Sometimes, in looking for something hidden, people find new facts about electricity, radiation, or the ways particles connect and interact. The search for dark matter helps science move forward, even if the answer is hard to find. This work is important because dark matter shapes everything. It helps galaxies form and hold together. It keeps clusters collected and lets regular matter gather so that stars and planets can exist. Without dark matter, the universe would not have the same shapes or motion. Every year, more data is collected. Each test, whether successful or not, adds a new piece to the puzzle. Even when a test does not find dark matter, it helps by showing which ideas are not true. This helps focus future searches and save time and effort by learning from each result. The search for dark matter is one of the biggest group efforts in science. People from all over contribute ideas, machines, and skills. They work together to handle problems and to test results. Science moves faster when people share information, and the study of dark matter brings people together from all over the planet. In the coming years, new kinds of experiments may appear. Stronger machines might be able to see smaller and weaker particles. New ways to test gravity, energy, or even the smallest signals might be invented. Each new try is a step closer to the answer. Finding direct proof of dark matter remains one of the greatest goals in science today. Knowing what it is made of, how it behaves, and seeing it interact even once will change our view of the universe. With each detector, each model, each careful experiment, science moves another step forward on the path to discovery. As new tools are built, and as more people join in the search, the hope grows that soon the truth about dark matter will become known and finally show what has been hidden since the universe began. Scientists hope that one day the true nature of dark matter will become known because learning more about dark matter will answer important questions not only about tiny particles but also about the largest objects and shapes in the universe. Dark matter is much more than just a puzzle for experts. It is one of the main reasons the universe looks as it does now. Its quiet mass plays a big part in the way galaxies, stars, and planets have formed and continued to exist, and it may influence how the universe itself will change over billions of years. Almost everything we see in space comes from the presence of both regular matter and dark matter working together. Regular matter is the kind that forms stars, planets, gas, dust, and every object we can find and touch. Dark matter, on the other hand, is the unseen helper. Its gravity acts everywhere, even if we cannot see or touch it directly. This gravity is what allows large groups of stars and gas to collect together and not fly apart. Without dark matter, the universe would be emptier and the shapes we know would not exist. One of the main reasons why dark matter is important is that it helps galaxies form and keep their shape. Many billions of years ago, when the universe was still young, it was a much simpler place. There were no stars, no planets, and no galaxies. It was mostly full of very hot, spread-out gas and light. Over time, as the universe cooled, dark matter started to draw regular matter together. Its gravity pulled the gas into clumps, making dense areas where stars would be born much later. If dark matter was not present, the gas would not come together fast enough. The universe would take too long to form galaxies. Some scientists believe that galaxies might never have formed at all. This would mean no clusters of stars, no solar systems, no planets, and probably no life as we know it. Dark matter made it possible for galaxies to gather and grow, setting the stage for everything that followed. As the universe kept changing, dark matter continued to do its invisible work. Inside galaxies, dark matter creates halos around the stars and gas. These halos are full of mass, and they help keep the stars from flying away when they move quickly around the center of the galaxy. Even in small galaxies, dark matter halos are needed to explain why the stars inside do not drift apart. Observations with telescopes show that without this hidden mass, most galaxies would come apart over billions of years. Dark matter serves as the glue that holds everything together. Not only does dark matter help galaxies form, but it also affects groups of galaxies called clusters. These clusters contain hundreds or thousands of galaxies all held together by gravity. Dark matter inside these clusters works the same way as in single galaxies. It holds the whole group together, letting the galaxies move around each other without breaking apart. Scientists have measured how fast galaxies in clusters move and have found that the motion can only be explained if there is much more mass present than what can be seen. This extra mass is dark matter. When looking at the biggest scales, dark matter controls how the entire universe is built. Over great distances, dark matter forms giant structures shaped like webs, with long strands that connect clusters and superclusters of galaxies. Scientists call these shapes the cosmic web. The bright parts we can see, stars and galaxies, are only small pieces in this huge web. The rest of the mass is invisible dark matter. These patterns would not exist without the special gravity from dark matter. It shapes the universe, making places where regular matter can gather, leading to the creation of stars, galaxies, planets, and even life. Dark matter has also made it possible for regular matter to cool and join together. When a gas cloud forms in space, it gives off heat as it gets smaller and denser. If there is no way for the gas to stop getting hotter, it cannot keep shrinking and become a star. Dark matter helps by making a deep well of gravity. The gas falls into this well, cools down, and can make new stars. Without the help from dark matter's gravity, the process would be much slower or might not work at all. The movement of stars and planets is also shaped by dark matter. When scientists measure the speed of stars, they find that many move faster than they should, based only on the visible matter nearby. This is seen in our own galaxy, the Milky Way, where stars spin around the center quicker than if only regular matter was pulling them. The hidden mass of dark matter makes this possible. Without it, the pattern of star movement would be wrong, and the galaxy would not stay together as we see it now. Even the formation of planets is tied to the effect of dark matter. Planets form inside clouds of dust and gas in galaxies. These clouds are made stable by the gravity of the whole galaxy, which is mostly shaped by dark matter's invisible weight. If dark matter did not exist, galaxies would not hold together. There would not be thick clouds of material, and planets would have a very hard time forming. Many planets might never have existed, and so the places where life could appear would be rare or missing altogether. On larger scales, dark matter affects the way the universe grows and changes over time. Since the beginning, the universe has been getting bigger, with all galaxies moving away from each other as space itself expands. Dark matter slows down this expansion in some ways because its gravity tries to pull things back together. Scientists measure how fast galaxies move apart and how this has changed over billions of years. The results show that the universe's shape and speed depend not only on regular matter but are also strongly affected by how much dark matter there is. If the amount of dark matter in the universe was different, many things would have changed. If there was much less dark matter, the universe would have become very empty, and most of the matter would be spread out, not gathered in galaxies and clusters. If there was much more dark matter, galaxies would have formed faster, and their shapes might be very different. The amount of dark matter has to be just the right amount to make the universe look as it does today, with many stars, galaxies, and places where life can exist. Another important idea is that dark matter plays a role in explaining how the universe began and how it may end. The earliest light we can see, called the cosmic microwave background, shows patterns that only make sense if dark matter was present at the very start. These patterns tell us that dark matter helped seed the early shapes and flows of gas and matter. Scientists use this data to understand not just the past, but also what might happen far, far in the future, billions or even trillions of years from now. The presence of dark matter also helps explain why galaxies come in different shapes and sizes. When scientists look at different kinds of galaxies, spiral, oval, or irregular, they find that the amount and spread of dark matter inside each galaxy changes the way it forms and moves. Galaxies with a lot of dark matter in their halos are more stable and can hold more stars. Galaxies with less dark matter may be smaller or may even break apart if they are disturbed. Dark matter also makes the universe more connected. Because it forms the cosmic web, it helps guide the movement of galaxies and clusters over very great distances. This means that the shape of the biggest patterns in space is not random. It is ordered by the invisible hand of dark matter's gravity. The connections in space have led to the rich mixture of large and small galaxies, to the streams and walls of clusters, and to the great empty spaces, called voids, between them. Even on small scales, the gravity from dark matter is felt. Scientists find that dwarf galaxies, which are the smallest kind of galaxy, need dark matter to stay together. Without it, their few stars would rapidly drift apart into space. When a cluster of galaxies collides with another, it is dark matter that keeps the final shape somewhat together, even as stars and gas move and heat up. Every part of the universe, from the biggest to the smallest, is influenced by the quiet presence of dark matter. The search for dark matter also brings many people together and drives new inventions. To hunt for something so subtle, scientists must build better telescopes, stronger computers, and new detectors. These tools help not only in the study of dark matter, but also in medicine, technology, and other areas of daily life. This shows that dark matter research, even though it is about space, has benefits everywhere. Knowing about dark matter changes the way we view everything. It shows us that what we see is only a small part of what is real. The universe is deeper, wider, and richer because of this hidden mass. Dark matter teaches us that big questions can be answered with patience, teamwork, and careful study. Every answer about dark matter helps explain other mysteries. For example, by knowing how dark matter works, scientists can test different ideas about why the universe expands or why galaxies spin the way they do. It may also help answer questions about other strange things in space, like energy that pushes galaxies apart, or the reasons behind very rare but powerful explosions seen far away. By learning more about dark matter, we can also learn about our own Earth and our origins. The small amount of atoms in our bodies, the air and the water, are only a tiny part of all the matter that the universe built. Most of the structure, shape, and history of our galaxy comes from the hidden hand of dark matter. In this way, even though dark matter cannot be seen, it has allowed life to exist and planets to be born. The study of dark matter is not only about finding out what it is, but also about understanding what the universe means. The presence of so much hidden mass is a sign that there may be many more mysteries ahead, things we have not yet found or cannot yet imagine. Each new discovery leads to another question, and dark matter reminds us that the universe is full of surprises. Our story is linked with dark matter at every moment. The stars we see, the night sky, the life on our planet, and the space we dream about, these are all shaped and held by the invisible mass that fills the universe. As scientists keep searching, building, and testing, the knowledge of dark matter grows. Every new piece of information brings us closer to the truth of what the universe is and how it can hold so many wonders. The search to understand dark matter continues every day. Scientists from everywhere work together with patience, careful planning, and hope. The mystery of dark matter is one of the largest puzzles in all of science because every clue brings more questions, and each new discovery helps reveal only a small part of the truth. The journey to understand dark matter is filled with successes, with setbacks, and with lessons that help science move forward. When people first noticed that galaxies and groups of stars did not behave as expected, they looked for answers by checking the amount of matter they could see. Over years and decades, the study of how galaxies move and how light bends showed that most matter in the universe cannot be seen. Scientists learned that regular matter, all the things we know and can touch, is a very small part. The rest, the majority, is invisible but makes a strong pull with gravity. This invisible material is called dark matter. Learning this was only the first part of the journey. After that first discovery, many questions came up. Where is the dark matter? What is it made of? How does it affect everything? People started to test ideas by building better telescopes, by creating strong computers, and by inventing experiments that could sense the smallest changes around them. New tools let scientists measure the sky and gather more information than ever before. The answers, however, did not come easily. Many experiments showed only hints. Sometimes a test would suggest that something new was found, but after deeper study it would turn out to be a mistake or something already known, such as a particle from the sun or a normal event in space. In this way, the study of dark matter has not only shown its mystery, but also made scientists be more careful and more precise. Every attempt to collect data is important, even if it does not give the answer. The results that do not find dark matter help to remove the ideas that are not correct. These failures guide the next choices scientists make. So every experiment, no matter the result, is a step forward in the journey. For many scientists, the search is not only for the particles or the signs that show what dark matter is, it is also a search for understanding about how nature works at its deepest level. Sometimes even the best computers cannot make strong predictions because the universe is so complex. So scientists test one idea, learn from it, and then invent another idea. Some people spend their whole careers studying only one part of this puzzle. Others share results and build on each other's work. Sometimes a new discovery changes everything. Over the last years, data from the oldest light in the universe, the cosmic microwave background, gave very new clues. This light shows the universe when it was very young, almost 14 billion years ago. The small changes in this old light fit best with the idea that dark matter was already there in great amounts. These changes help scientists test which ideas about dark matter can be correct and which are not. Other changes in thinking come from new ways to see and measure the universe. For example, using gravitational lensing, scientists learned much more about where dark matter is placed. With this tool, people can make maps of mass, even when there is nothing shining or visible in that space. In some places in the universe, maps of lensing proved there is much more mass than regular matter alone could supply. This is one more reason why dark matter is a strong idea. Groups of people from many countries build large machines and share information so the search can move forward more quickly. Working together helps bring more ideas and new skills. Some teams look very deep under the earth for signals. Others watch the sky or work with computers to create models of how galaxies move. By connecting all these efforts, science can use many different ways to look for answers. This process means that sometimes results are unclear, confusing, or not expected. When this happens, scientists do not stop. Instead, they ask new questions and make better experiments. Sometimes, a test will find a signal that looks new and interesting, but after careful work, they may find that it is a signal from something known or a small mistake. This careful checking is important so that only true discoveries are shared. Exploring dark matter has led to many lessons and rewards beyond only learning about invisible matter. The search has made new machines for science, for health, and for technology. Some tools made to look for dark matter are now used to study cancer, to find minerals, or to check for clean air and water. This is because the journey for answers often helps make many new things that help daily life, not only science. Even when the main puzzle remains, smaller discoveries are made. One experiment may help show what other particles exist, how regular matter behaves when it is very cold or dense, or how gravity and light work at the smallest level. Each lesson gives new ideas for future tests and gives hope that the mystery of dark matter will one day be solved. Looking at the stars, galaxies, and the largest shapes in space makes scientists ask not just about how the universe moves, but about why it exists in its special way. The presence of dark matter is a message that there are still secrets in the universe waiting for answers. Every day the search continues, led by new discoveries, new people, and new questions. One lesson from the search for dark matter is that science is always changing. What people believed 50 years ago, or even 10 years ago, can be very different from what is thought today. As more information is found, the story of the universe becomes clearer, and the role of dark matter becomes even more important. In the past, many thought only what could be seen mattered. Now, we know that the biggest part of the universe is what cannot be seen at all. Another lesson is that patience is needed in the search for truth. Some mysteries are solved quickly, but others, like dark matter, need many years or even many lifetimes of work. Each small step, each new idea, each careful test is valuable. By working together and by sharing ideas, progress continues, even if the final answer is not yet in view. Dark matter also teaches us that big ideas can come from simple questions. The question, "Why do stars move this way?" opened the mystery. The question, "Why does light bend so much?" led to new tools and methods. Every question brings the chance for learning and for discovering something new. The journey for answers leads people to search far beyond Earth. People now look deep into space and try to see as far back in time as they can. They build machines to help them measure tiny things and giant things, to test ideas old and new. With each new tool, each new experiment, the picture of the universe grows wider and deeper. There is always a chance for surprises. Sometimes a test for dark matter might find something else, like a new kind of particle, or a new way that gravity works, or a new unknown in nature. These surprises are often the things that let science grow most quickly. Even a failed experiment is useful for what it teaches. During all these years, scientists keep a careful record of their work. They write down each test and all the results so that others can check every detail. This helps others learn from mistakes and learn from successes. Open records and sharing of data help everyone move forward faster. Each generation of scientists uses the notes left by those before. Every answer, every new finding, and even every new question leads to more discoveries. Science moves step by step, building a picture that shows the whole universe and our place in it. The journey for answers is as important as the answer itself because it teaches people how to look, how to plan, and how to work together. The story of dark matter is also about hope. It is about believing that even when answers are hard to find, careful work and new ideas can bring the truth closer. It is about sharing, teamwork, and never giving up. The mystery is big, but science is patient and continues the search. People who work on dark matter do not always know if the answer will come in their lifetime. Some only hope that their work will help the next generation get closer to the truth. They think about the future, so that children and grandchildren will know more about the universe than they did. Every day, new students join the search. Some read about the stars and space at school. Others see pictures and videos, or use computers at home to explore the sky. Many become scientists, mathematicians, engineers, or people who build tools and machines. Everyone who learns or teaches in big ways or small is helping in the journey to understand dark matter. The journey to solve the mystery of dark matter is full of wonder. It makes people dream, imagine, and hope. Looking for answers is a sign that humanity is always searching, always wanting to know more, never finished with the question of where we come from and why the universe exists the way it does. Through every failed test, every noisy signal, every new idea, the search moves forward. Even though most of the universe is invisible and hidden, people do not stop looking. The path is long, the work is slow, but the dream of discovery continues and always grows. The mystery of dark matter connects everyone who loves to learn. It shows that there are things in the world and in the universe that are still unknown. It teaches that every question is a sign of curiosity, and every new idea is the first step to a new truth. Even when the puzzle is not yet finished, the journey itself changes those who take part, building new tools, new ideas, and a deeper understanding of the universe. The future of this search brings hope, and with every new person, machine, and idea, the day comes closer when dark matter will no longer be a mystery, but will be part of the answer to why the universe is as wonderful and surprising as it is. The search for answers about dark matter keeps moving forward with hope and determination. Every day brings more people, more ideas, and more powerful tools to the worldwide team trying to solve this giant mystery. The story of dark matter continues because with each discovery, new questions open. Each step on this path is a chance to find something that will change what we know about the universe. Technology is always getting better. People now have machines, computers, and telescopes that are stronger and more precise than those of the past. These tools let scientists see farther, measure more accurately, and gather more information in a single day than in many years before. New detectors are made to find even the smallest sign that dark matter is real. Each improvement brings more hope and more chances to find out the truth. Space telescopes look out to distant galaxies, clusters, and the oldest light in the universe. They watch the way stars move, how light bends, and where regular matter comes together. These telescopes send back huge amounts of pictures and data. Astronomers study this information to find small clues that point to the presence of dark matter. Some signals may be very faint, but new computer programs can help search through the information much faster and better than ever before. Underground labs, hidden deep under mountains or in old mines, continue their tests. Each lab is trying a new way to find the particles that might make up dark matter. They use very pure materials, colder temperatures, and more sensitive machines. The people who work in these places spend many months watching and waiting. They share their results with scientists around the world. Sometimes they find a strange signal, and the whole team works together to check what it could be. Even when there is no new discovery, each test helps rule out some ideas and helps design the next experiment. Big efforts are being made at places like the Large Hadron Collider and other particle physics labs. These facilities smash particles together and look for something new to be made, something that cannot be seen by the usual machines. Whenever some mass or energy is missing after a collision, it could be the first sign of a new kind of matter. Every year, these labs get updates and better technology to test new ideas and reach higher energies, hoping to see the signal they are searching for. The future may bring even newer tools. There are plans for larger and better telescopes to be sent into space, even more powerful than before. Scientists want to build even bigger underground labs with huge detectors. With more funding and teamwork, These new projects could be ready soon and give a better chance to see dark matter directly. Even as tools get better, people also try new ways of thinking. Some teams create computer simulations to test new ideas about how the universe would look if dark matter was made of different things. These models become more real as computers become more powerful. They help check which kinds of dark matter agree with what is really seen in the sky and which do not work. Education and teamwork are a huge part of the search. Schools and universities help train future scientists, engineers, and thinkers who will join the dark matter search. Teachers show the value of curiosity and careful study, and they encourage questions from new students. Every scientist working on dark matter was once a student who wanted to know more about the universe. By supporting learning, people open the way for more discoveries. Science fairs, museums, and educational websites help share new facts and questions about dark matter with people of all ages. As more people learn about the universe, the search for dark matter becomes a story that everyone can join. Sometimes, a simple question from a student can lead to a new way of looking at the problem. Each new person brings a new idea or skill that can help solve the puzzle. Better communication also helps scientists share their results. With fast computers and the internet, a discovery in one country can be shared everywhere in seconds. Many teams from different places join together, combining their strengths to make tests, compare data, and plan new experiments. This teamwork makes the search faster and more careful. Private groups, universities, and governments are investing money, time, and trust in the search for dark matter. They help build the laboratories, pay for the tools, and train the smart people needed for this work. The size of these efforts shows how big and important the question of dark matter has become. By working together, the world increases the chance of finding the answer. The study of dark matter is also linked with other big questions. For example, many scientists want to know why the universe is getting bigger faster, a process called cosmic expansion. Some think dark matter and another strange thing called dark energy may be related. By learning more about dark matter, we could also find clues to solve other mysteries. All of these steps will bring rewards to other areas of life too. To search for something that is invisible, people have to invent new tools and technology. These inventions sometimes help with medicine, safety, energy, and many unseen challenges. The search for dark matter pushes technology forward in many ways. People working on this puzzle have already made sensors, magnets, computers, and programs that help in fields far away from space science. The questions about dark matter also help us see how science works. Slowly, step by step, checking and learning. Some discoveries take many years, but each part helps us learn. When a piece of the puzzle is found, it can change everything people know about nature and space. The story of regular matter and dark matter shows how much more is left to learn, and it asks everyone to keep searching. People wonder what will happen when the answer is finally found. Will we see the dark matter particles, or make them, or use them in new ways? No one knows for sure, but everyone agrees that the answer will change our understanding of the universe forever. Knowing what most of the universe is made of could open new doors and lead to discoveries that cannot be imagined now. The future might bring answers about how galaxies formed, why the universe started in the way it did, and how long everything will last. Some scientists hope that, after finding dark matter, we will be able to understand the very beginning of everything in more detail. Others hope to discover new particles or new forces. Some even dream of learning not just what dark matter is, but also if there are hidden parts in nature that we have never seen or tested. The path ahead will still have many challenges. Each experiment must be carefully checked, and each signal must be tested again and again. Sometimes more questions will arise instead of answers. That is the way science moves forward. No good discovery comes quickly or easily, especially when dealing with something so hard to find as dark matter. Still, each year brings progress. New students, new scientists, and new ideas fill the field. The excitement of the search creates hope and makes many people want to learn science, try new things, and work together. These qualities are important not only for dark matter but for solving many problems in science and life. One day, perhaps sooner than people expect, the answer to the dark matter mystery will become clear. People everywhere, adults and children, will read about it in books or see it in news from around the world. At that moment, the long search will become a celebration, and scientists will look back and see how every step was needed to reach that point. Even then, more questions will come. The story of science always has another page. With each mystery solved, a new one often comes to light. This is because the universe is very big, full of unknowns and secrets. The search for dark matter reminds us to keep looking, asking, and learning forever. This is why the search for dark matter is not just for scientists. It belongs to everyone who looks up at the night sky and wonders what is out there. It includes teachers, students, dreamers, and builders. Every new question matters, and every step takes us a little further. The future of dark matter research is about teamwork, curiosity, and hope. As technology improves and new people join, the research will grow in new directions. Better detectors will hear quieter signals. Bigger telescopes will see farther and clearer. Smarter computer programs will solve harder puzzles. New ideas will appear, and old questions will find answers. All of this will come from the work, dreams, and questions of people everywhere. The universe is still mostly a mystery. Regular matter makes only a small part, while dark matter is the hidden mass that shapes everything. Learning about dark matter is not just about space. It is about discovery, teamwork, invention, and curiosity. Each step helps build a world where anyone can join the search. The end of the search for dark matter is really the beginning of more discovery. With every experiment, new truths are found. With every question, new doors open. The journey will inspire more children, more science, and more stories of wonder. The answer to dark matter will be a gift from our generation to everyone who comes next. A sign that people did not stop searching, did not turn away from hard questions, and kept reaching for the stars.